In this video, we're going to look at conditional statements in Java. To start with, we need to look at Boolean expressions. A Boolean expression is a statement that evaluates to either true or false. So, is 6 equivalent to 9? That's a Boolean expression. And obviously that's false. Programming languages use comparison operators to express Boolean expressions. So again, back to is 6 equivalent to 9? In Java, we would write that as follows. And of course, it's still false. George Boole is one of the fathers of Boolean logic. If you're looking for some light reading, maybe jump on the Wikipedia page and take a look at the history there. A comparison operator is an operator that's used to compare two things. So Boolean expressions require the use of comparison operators. And here we have a number that are available to us in Java. We have equivalent to. And really important, we say this equivalent to, not equals to. The reason why we say this as equivalent to is because if we say equals, so if I say x equals 9, it implies that I'm putting 9 into x. So it's an assignment statement. So if I want to say, check if x has 9 in there, we say is x equivalent to 9. Not equivalent, greater than, less than, greater than or equal to, less than or equal to. These comparison operators might change based on the language, but the principles are the same. So let's look at a couple Boolean expressions. Like I said, they can always be evaluated to either true or false, and we always read them from left to right. So, this one, 6 is equivalent to 7. That's the statement, and that statement is false. 6 is not equivalent to 7. That is true. 8 is greater than 9. That is false. 102 is less than 102. That is false. 9 is greater than or equal to 9. 9 is greater than or equivalent to 9. So you'll notice here I'll use equivalent or equals to. It's really only in this first case here that I always say equivalent. And you know, as you become a more experienced programmer, you become a little more relaxed at that. But again, my introduction course, I like to keep this consistent. It helps us communicate our ideas. And of course, 9 is greater than or equal to 9, so that's true. 67 is greater than or equal to negative 12. And that's true. So these are Boolean expressions. And we eventually will apply them to variables. So on the left-hand side here, I have a snippet of code where we have 2 integers, a double, and 4 chars defined. And over here, this would be read, is x equivalent to y? And if we look at the values contained in x and y, that's obviously false. Is z less than or equal to y? So we look at the values again. Z is 12.3 and y is negative 23, so that's false. We can do mathematical operations on the left and right side of the comparison operator. So x times y is not equal to z times 10. So x times y is going to be negative 230. Z times 10 is going to be 123. So that's true. Comparing characters. So for the most part at this stage, your character comparisons will be pretty straightforward. It's going to be, is a variable equivalent to a? In some, say, multiple choice type question. But let's talk briefly about what Java actually does when it compares characters, because it actually becomes useful for some more complicated problems. Characters actually get mapped to specific integer values before they're compared. And you can jump online and do a search for ASCII table in Java, and you'll get that character mapping. But I'll tell you that capital A is mapped to the number 65, and capital Z is mapped to the number 90. Small a is mapped to 97, and small z is mapped to 122. And then, of course, sequentially in between 65 and 90 are the other capital letters. Between 97 and 122 are the small case letters. So notice, any lowercase letter is going to be greater than any uppercase letter. So capital A is mapped to 65, small d is mapped to 100, capital W is mapped to 87, and Q is mapped to 113. So if I say is C1 equivalent to C2, well, we can see obviously capital A is not equivalent to capital D, so this is obviously going to be false. but that's what Java actually does. Is C2 less than C3? So this is a little bit of more of a not as conventional way of comparing characters, but it is useful for some things. We want to understand that Java simply maps those integer values and does a comparison. So if C2 is 100 and C3 is 87, that's like saying is 100 less than 87, and that's false. C4 greater than C1, so again, C4, which maps to 113, C1 maps to 65, and that is true. And we can do some we can add characters together as follows. So if we say C2 plus C3 is less than or equal to C1 plus C2, it's going to map all of those characters to their integer values, do the respective math, and then work out the value. Again, at this stage, for the most part, we're simply checking if the user inputs a specific letter. So we're really using, for the most part, equivalence. Where this mapping becomes particularly useful is if you're doing some password programs or some programs where you might want to shift a word. There's a really interesting Waterloo Computer Science Contest question about creating passwords. I believe it was the 2014 year. So, what's a conditional statement? So let's forget about programming initially, and let's start by thinking about real life. If you clean your room, then you can play video games. So a conditional statement is a statement that can be evaluated to either true or false, and then based on what's chosen, you take some sort of course of action. If you are not in uniform, then you will receive a uniform infraction. That is, if you happen to go to a school with a uniform. If you like ice cream, then you will get ice cream. Well, we could add these things, this is called an else. So if you like ice cream, then you will get ice cream. So there's the true branch. Else, you get cake. So a conditional statement is simply a statement that you evaluate, and then if that statement evaluates to true, you take a specific path. You can also set it up such that if that statement is false, you take a different path. So a conditional statement in programming looks like this. In Java, we write the word if, we open a bracket, and then we put our Boolean expression inside of here. And then we have an open a brace, close brace. This is the true code segment, and this is what the flow diagram looks like. Our program will flow from the top, encounter this conditional statement. If it's true, it travels and executes the statement. Continues. If it's false, it just skips that statement. If I want to put an else on it, I can add an else to the if statement here. So if the condition evaluates to true, I take that statement, I evaluate this statement here, else I take this branch. So let's look at this example again. If you like ice cream, then you get ice cream, else you get cake. What if there are more than one dessert option? If you like ice cream, then you get ice cream. Else, if you like cake, then you get cake. Else, if you like fruit, then you get fruit. So again, these flow diagrams you'll come across them, and they're helpful when you're trying to code out some more complicated problems. But the idea here is that if you like ice cream, I'm then going to give you ice cream. Notice, if you say, I like ice cream, I'm not going to ask you if you like cake or if you like fruit. I'm simply going to go down to the bottom and continue on. So else ifs only get evaluated if the previous statement is false, right? Imagine you're in a restaurant and someone comes up to you and you're allowed one dessert. They're going to say, do you like ice cream? If you say yes, they're going to get you ice cream. But they're not going to ask you about the other options because you've already made your choice. So else ifs have to be connected to some initial if structure. We could add at the bottom of this, else you get chocolate. So the question is, here's our little chocolate, right? So you don't like any of the options they've given you, so they're just going to give you chocolate, because everyone loves chocolate. Where would this go? That would just fill right in there. So notice, this fits right there in my logic diagram. So this is an example of if and else if structure. So we have an if this evaluates to true, we have statement 1. If this is false, we look at else if, we evaluate that Boolean expression. If it's true, we take that. If this is false, we take this. Boolean expression, true, we do that. We can put as many of these as we want on here. The key thing is that the minute we find a condition is true, we skip the rest. So notice, if the first condition is false, I come to the second condition, which is true, and I take that path. Notice I skip all the other else ifs. And again, I can add an else. That's like if all else fails, we do that. And it kind of fits right in there in our conditional structure. Else ifs and elses have to be connected to some starting if statement. And like I said, we can have as many of these as we want in there, with an else if we choose. So really, just in brief, this always happens when students are starting to learn how to program, is they try and compare strings, and they write something like this, and then it doesn't work. And you say, well, it should. Without getting into too much detail at this point, you can't compare strings with an equivalent sign. You have to use a special built-in method for a string. A string is what's called a reference variable. So if you use an equivalent sign, you're not actually comparing what's located in the variable. You're comparing where the variable is, which inevitably will be false for the most part at this stage. So if you want to compare strings, you have to use this method called equals. And here it is. Again, I'm not going to actually explain how this works quite yet, but students often want to do this, so I put it in there. And again, you can take a look at one of my videos about strings if you're interested. So main moral of the story right now, good, bad. Okay, the big takeaway here is that you cannot compare strings using an equivalence operator. And like I said, for more detailed expressions, see the presentation on strings. So we also have these things called logical operators. So we have two operators. We have the AND operator and we have the OR operator. So the AND operator, which is notated like this in Java, it can be used if you want multiple things to be true. So for example, let's forget about programming again. Remember this one? If you clean your room, then you can play video games. Well, what if I say, if you clean your room, then if you take out the garbage, then you can play video games. So notice there's two things that have to be true now in order for you to play video games. So notice, this first one has to be true, and then I check this, and the second one has to be true. If either of those fail, you don't get to play video games. Well, I could write this as, if you clean your room and you take out the garbage, then you can play video games. So I could write it in one conditional check, right? Same idea here. Let's change it up again. Let's change up the requirements to play video games. If you clean your room, then you can play video games. Else if you take out the garbage, then you can play video games. Well, notice how both of these have the same outcome. So one could say, if you clean your room or you take out the garbage, then you can play video games. So what we could do is we could condense that into one conditional structure. As follows: if you clean your room or you take out the garbage. So if either of these are true, you can play video games. Otherwise, you don't get to play video games. So let's look at some examples of Boolean expressions with logical operators. So this would be read, is 6 equivalent to 7 and is 9 greater than or equal to -1? Well, the first condition is false and the second condition is true. So in order for the outcome to be true, they both have to be true. So the outcome here is false. Here we'd say, is 9 greater than or equal to -1 and is 6 equivalent to 7? Well, again, they both have to be true in order for the outcome to be true. So the outcome here is false. There's all sorts of little shortcuts and tricks when you're working with this, and at this point, we're just going to evaluate them from left to right. But a nice little thing to highlight here and to be aware of is that Java is kind of smart. If the first condition evaluates to false, it doesn't actually look at the rest of the conditions. It actually will just ignore them. So here, 6 equivalent to 7, or is 9 greater than or equal to 1? Well, this is an or statement means if one or both of them are true, then the outcome is true. So 6 equivalent to 7 is false. 9 is greater than or equal to negative 1 is true. The outcome is true. So here's an or. Is 9 greater than or equal to 1? Negative 1, that's true. Or is 6 equivalent to 7? That's false. So again, since one of them, or both of, since one of the two is true, the outcome is true. And with if statements, again, Java has some efficiencies built in. If I ask you a question, if I have a set of questions to ask you and only one of them needs to be true for me to move on, I'm only going to ask you that first question. So notice here, whereas this first example, we'd have to evaluate both of them to get the outcome true. Java would look at this first one, see that it's evaluated to true, and ignore the second one. This is a little idea that isn't significant at this point, but this idea of precedence and these shortcuts is called short-circuited conditional structures. It's really useful when you start getting into some object-oriented principles. So again, there's a whole set of precedents designed around Java, and it's worth taking a look. But at this stage, I'm not too concerned about students memorizing the exact order of operations in terms of the precedences. You can always force things with brackets. So what would the below statements print here? Well, this inside would evaluate this Boolean expression, and for now we're just going to evaluate them from left to right. If for some reason I wanted this to be evaluated first, I could put an extra set of brackets there. So this is going to be false and true or true. False and true evaluates to false. False or true becomes true. This one's going to be true or false and true. True or false and true. Evaluate the first two. True and true. So again, there's a subtle point here. And and or operators are called short-circuited. That means if the first condition evaluates such that the rest can be ignored, it will be. This is really useful in dealing with conditional statements and what are called null pointer exceptions. If you're in my class at this point, you don't need to know what that is. But it is something I want you to kind of put at the back of your mind, because it will come up a little later this year. So even though and has precedence over or, this short-circuited behavior will seem to contradict this. So I think what we're going to do is we're going to stop here, and we'll continue this in another video.